Hello friends, today we're going to talk about compound inequalities. Compound, like a compound word, is just putting two inequalities together. So for these compound inequalities, you're either going to see or and, or there's going to be a situation where a variable is squished between two numbers or squished between two inequalities. If you see the word or, your inequalities are going to end up going in opposite directions. So just like the word or, the inequality means that it fits, or your graph shows that it's any number that fits either one of those inequalities. We're going to solve them the same, except we just have two separate ones to solve. So for our first one here, we'll take away 6 from both sides. We'll get negative 3p greater than negative 6. And then we're dividing by a negative. Recall, when we divide by a negative, this inequality symbol switches to its opposite. So our final answer is p less than positive 2 for that one. Now let's solve the other one. I'm going to subtract 3. So then I get 8p greater than 48, dividing by 8. Here I'm dividing by a positive, so I don't need to switch the symbol, and I get p greater than 6. So our final answer then, we need the or, p less than 2 or p greater than 6. So when we graph this, because it's an or, they should be going in opposite directions. So I have a 2 and a 6. Both of them are open circles, so an open circle at 2 and everything less than that. And then also an open circle at 6, everything greater than that. So any number that's in the shaded region satisfies one of the two inequalities. So any number that's less than 2 or any number that's greater than 6. Let's look at another one. Divide both sides by 3, and I get a greater than 10. Add 2 to both sides, and I get a less than or equal to 7. Let's not forget our or. When we graph it then, again, we're going to have a 2 and a 7. Not a 2 and a 7. A 7 and a 10. Let's look at the 7 first because it's farthest left. We have a closed circle at 7 and shading to the left, an open circle at 10 and shading to the right. So again, they're going in opposite directions. Let's look at one more, or. I'm going to start by getting all of my variables on the same side. So I have negative 2 plus 2m less than negative 10. Adding 2 to both sides, I get 2m less than negative 8. And then dividing by 2, we have m less than negative 4. Now looking at the other one, I'm going to start by subtracting 3m, getting all my variables on the same side. So then I have m, or 1m, take away 5, greater than 1. Adding 5 to both sides, I'll get m greater than 6. And remember, this is an or, so m is either less than negative 4 or greater than 6. So when I graph this on my number line, I'm going to put a 4 and a 6. I'll deal with the 4 first because it comes first. Oh, that's negative 4. Negative 4. I'll deal with that first because it's the farthest left. Less than negative 4 means an open circle going to the left. Greater than 6, open circle going to the right. So again, notice on all three of these examples that the inequalities are going in opposite directions. Now we're going to look at some ands. If it's and, That means the inequality is squished between the two numbers. Okay, you're either going to see the word and, or you're going to have an inequality like this one, where it's kind of the inequality itself is squished between two numbers. This implies and. So let's look at this one. We'll solve them separately. Take away 3, take away 3. We have r less than -7. And then looking at our second inequality, I'm just going to rewrite it down here so I have a little bit more room. Opposite of dividing by 4 is multiplying, so we'll multiply both sides by 4. And we get r greater than or equal to -8. So there's two ways we can write this. I can either write r less than -7 and r greater than or equal to -8, or I can write it -8 less than or equal to r less than -7. Notice here that the bigger part is facing toward the r, and that bigger part is facing toward the r. Here, the smaller part is facing toward the r, and the smaller part is facing toward the r. So either one of those ways works to write your final answer. To graph it, though, it's just going to be squished between -8 and -7. Greater than or equal to -8 means we're going to color in that circle. Less than -7 means we leave it open and we shade in between the two numbers. Let's look at this one. Now this we can split up into 11 less than n plus 10 and n plus 10 less than 14. So again, I split it up. That was one inequality. This is a second inequality. So solving this, subtract 10, and 1 less than n, or you could say n bigger than 1, means the same thing. Here, subtract 10, n less than 14. So again, there's two ways we could write it. We could say n less than 1 and n greater than 14. Or you can write it as one big inequality with the n squished in between. So n is between 1 and 14. Your final answer, though, should be one of those two that I highlighted. So we have 1 and we have 14. Both of them are open circles. And our final answer is everything in between those two numbers. Let's look at this one. Again, we're going to split it up. So our first inequality v plus 4 greater than or equal to -6 plus 2v. And then our second inequality, again, the part that's in the middle is going to be part of both inequalities. So then we have -6 plus 2v greater than or equal to v plus 2. So solving these two separately, I'm going to get all my v's on the same side. So then I have -1v plus 4 greater than or equal to -6. Take away 4, -1v greater than or equal to -10. Dividing by -1. I'm dividing by negative, which means I need to switch my symbol. So then it's v less than or equal to +10. Now let's solve the other one. getting all my v's on the same side. Negative 6 plus 1v, or v, greater than or equal to 2. And then adding 6, we'll get v greater than or equal to 8. So again, you can either write it with an and, or you could write it as one big inequality. The 8 should come first, less than or equal to v, less than or equal to 10. Again, notice that the bigger part is pointing toward the v there, and the bigger part is pointing toward the v when I rewrote it. So when I graph this, I have my 8 and my 10. These both have the equal sign with it, so we're gonna have closed circles and shaded in between those two. So again, notice with all of the ands, it's between the two values. All of the ors, they're going in opposite directions. Let's try some trickier problems here. Usually trickier problems are where the variable goes away and we have to figure out what that means. Or you may get something that doesn't make sense. So let's look here. This is an or, so I'm gonna do these separately. Take away x, get 6x plus 7 greater than or equal to negative 5. Take away 7. So 6x greater than or equal to negative 12. Dividing by 6, x greater than or equal to negative 2. Notice I did not switch the symbol because I'm dividing by a positive number. I only do that if I'm dividing by a negative number. Let's look at the second one. I'm going to get my x's on the left here. So take 9x. Then I have 5, take away 4x, less than 1. Subtract 5, subtract 5. Negative 4x, less than negative 4. Divide by negative 4. So here I'm dividing by a negative. I need to switch my symbol. So I get x greater than positive 1. This is an or situation. Because it's or to begin with, I need to include or in my final answer. So now I know I have a negative 2 and a positive 1. Normally when we see an or, they go in opposite directions, but if we look at this one, greater than or equal to negative 2 means I color in, I have a closed circle, and then shading wise, it's everything bigger than negative 2. Now let's look at the x greater than negative 1, greater than 1, would be an open circle, and it would still be shaded to the right. So these ones do not go in opposite directions. So you have to be careful and actually graph each one to make sure that it is what you think it is. In this case, everything's going to the right, so we really are going to have a closed circle at negative 2 and then shaded to the right. That x greater than 1 doesn't really make a difference because all of those values have already been included in the x greater than or equal to negative 2. Let's look at this one. Taking 9x, taking 9x. We get negative 1x. Take away 10, less than negative 3. Adding 10, adding 10. We have negative 1x less than 7. And then dividing by negative 1. Because I'm dividing by a negative, I need to flip my symbol. So I get x greater than negative 7. Now let's look at the second one here. I'm going to add 3x And if we notice, when I add my 3x's here, the x's go away. So I'm left with 5 less than 1. So we talked about this last section. If the x's go away and you're left with a true statement like this one, then the answer is all real numbers. So because this is a true statement, the answer is all real numbers. So regardless, since one of these is all real numbers, that means the whole thing is all real numbers, which again just means that we shade from arrow to arrow here. Any number in the world makes this true. Oops. Let's look at one where there's no solution then. Here, if I take away 8k, take away 8k, I get 3 greater than or equal to 7. Well, my variables went away and I'm left with a false statement. And again, when you're left with a false statement, that means this one, this part at least, has no solutions. And because this is an and, if one of them has no solution, the whole thing is no solution. So again, I would just draw a number line and leave it blank because there's no solution. So to go over that again, if it's an or, and one inequality is all real numbers, then the whole answer is all real numbers. If it's an and one inequality is no solution, the whole answer is no solution. All right, have a nice day.